Alright, in this video we're going to evaluate numerical expressions. In other words, we're going to apply the properties of exponents, but with numbers. There will be no variables. Alright, so for example, if I had negative 9 times negative 9 to the third, right, I want to evaluate this. Alright, so to evaluate, if you notice here, the bases are the same, and I am multiplying. So really, I can add the exponents. Now, what's understood to be here? If there's no exponent written here, it's understood to be a 1. So really, I have negative 9 to the first power times negative 9 to the third power. So then, keep the base, and now I can add the exponents. So 1 plus 3 is negative 9 to the fourth power. And do not forget the parentheses, because the parentheses, we want to make sure we include the negative, because that's how they have it written first. Alright, and if we need to use a calculator, we can use a calculator from there if we need to. Let's do another example. Let's do 5 squared divided by 5 to the fifth power. Notice I'm dividing and the bases are the same, so that means I can keep the base. Now since I'm dividing, I subtract the exponent. So I take the numerator exponent minus the denominator exponent. So then 2 minus 5 is negative 3. You cannot leave your answers with negative exponents. So that means I have to rewrite this with a positive exponent. Well, the property of negative exponents says that I have to take the reciprocal of this, so it becomes 1 over 5 cubed. And then again, that's the same thing as saying 1 over 125, which is the same thing as 5 cubed. All right, and again, no decimals. All right, so therefore you must keep it as a fraction. What if I have 5/9 all of this to the negative third power? So there's a couple ways you can approach this. I can go ahead and deal with the negative right now, or go ahead, work with the 3, and then deal with the negative later. In this case, I will like to, since this is all one term inside, right, to distinguish between how many terms I have. Do I have any plus, any addition and subtraction going on inside? I do not, so therefore I only have one term. So that means if I want to do the reciprocal, which the negative exponent means, I flip this. So it becomes 9 over 5 to the positive third power, because the negative tells me to flip it. Now, I can go ahead and distribute the exponent. So it would be 9 cubed over 5 cubed. And again, we can use the calculator if we need to know what the 9 cubed is and then what 5 cubed is. Let's do 4 to the negative 2 over 4 to the negative third. Now, can I do anything with these exponents? Yes, because the bases are the same. So I keep the base, take the numerator, minus, because it's division, the denominator. So we have negative 2 minus a negative 3, so it becomes plus 3. So then for negative 2 plus 3 is 1. So 4 to the 1 power. You can leave it like that, or it's just saying it's 4. 2 to the negative 4 to the negative 2. Now this is a power of a power property. So I got an exponent that has its own exponent. I showed you 2 ways of doing this. We could do negative 2 to the negative 4th times 2 to the negative 4th. So there's 1, 2. So there's 2. Okay. Or the shortcut is, since it's a power or an exponent with an exponent, I can just multiply those exponents. It would be negative 4 times negative 2. So negative 4 times negative 2 is a positive 8. And there's your answer. Right? And again, we're evaluating this because we're actually getting numerical values for these expressions. do a couple more, and you should be good to do your first bookwork assignment. Let's try 6 squared all over.
Attention all students, it's 6 o'clock. The 3 o'clock activity buses are now arriving. The 3 o'clock activity buses are now arriving.
The buses are coming. Just in case you wanted to know. All right, so here we go. Putting those steroids to these problems here. All right, so if you notice here, this is all one term inside. Okay, you need to be able to do this without a calculator. All right, so you try and simplify the denominators more. All right, so it's all one term inside. So therefore, now, this is 6 to the negative 2 times 5 to the first power. Can I add these two exponents? No, because the bases are not the same. So therefore, I can't do anything with these. But I have a negative 2 out here, which means I can distribute to that. So really, I can rewrite it as 6 to the negative 2 to the negative 2 times 5 to the first power to the negative 2. Right? I just distributed the exponent. Now I'm going ahead and clean it up a little bit. So I got 6 squared. All right, so negative 2 times negative 2, because I have an exponent with an exponent, so that would be 6 to the 4th power times 5 to the negative 2. All right, now, is there anything else I can do here? Well, I notice here, these two have the same bases. I'm dividing, so that means I can subtract these exponents. 5 I can't do anything with right now. All right, so we have, okay, 6 over 2 divided by 6 over 4 times 1 over 5 to the negative 2. Now the reason why I did this is 6 squared times 1 is just 6 squared. I put it apart, so that way we can focus just on that part, because these are the ones that have the same base. So the bases are the same, so I keep the base. Now so I take the numerator minus the denominator. Right, again, I'm not doing anything with this one yet. Now 6, 2 minus 4 is negative 2. And 1 over 5 to the negative 2. Now, I can't do anything else with these bases because they're not the same. But I have negative exponents, so I got to rewrite these without negative exponents. So remember, the negative exponent tells me to take the reciprocal. So this becomes 1 over 6 squared, and this one becomes 5 squared over 1. All right, and then we can just rewrite it. Remember, when we're multiplying fractions, we can multiply across. So 1 times 5 squared is 5 squared, and you get 6 squared on the bottom. You can leave it like this, but in this case, we can actually evaluate this without a calculator easily, because 5 squared is 25, 6 squared is 36. All right.